Good morning, everyone. So let's get started with the session. Hello, everyone. I'm Karthiha, EC batch of 2022. I hope everyone are doing good. So I'll be the host of today's Huddle session in the topic of embedded system and electronics. I hope this session is being very informative discussion to every one of you who have joined here. Next slide. So I'll introduce the panel speakers who have joined for the discussion. First is Sujana Ramesh from the EEE department of batch 2020, and she is currently working in John Deere. And our next speaker is Bhavya Krishna from EEE of batch 2020, and she is currently working in Western Digital. And the third speaker is Amritha from EEE batch of 2020, and she is currently working in NVIDIA. And our next speaker is Madhavi Ravanan from IS department batch of 1998, and she is currently working in Nokia. And our last speaker is Angela from EEE department batch of 2006, and she is currently working in Power Grid Corporation of India. Next slide. So in this session, we'll be deeply diving into the tech in the 5 topics, that is embedded software, firmware development, electronics and ASIC development, 5G systems, and power systems. And apart from the discussion, we'll be having icebreaker sessions and some activities to engage all of you. So that you will also be getting to know how much you have understood from the session and how things have been for you. And I'm looking forward to the session to get to know a lot of things. Next slide. So now it's a ice-breaking session. Here's a workflow. Like, you can either go to menti.com and use the code that is shown in the slide, or a link will be shared in the chat box. Just a minute, we'll share the link. Guys, the link is shared in the chat box. So once if you go to this link, you'll be able to see a question like where you can enter the words that you know related to embedded systems and electronics. I would request all the mentees and other attendees to be it's the word hurdle slide. No, the other. I mean, in the the last one. Guys, go to the latest link that is being shared. So once going to that link, you can type what are the words that you know that comes into your mind when you think about embedded systems and electronics. Okay, I could see few words coming up. Okay, so there are quite a many words like microprocessor, microcontroller, Arduino, Raspberry Pi, sensors, and IoT, VLSI. We'll give you another minute so people who haven't filled it up can fill the fill in the link. Okay, so there are like lot many words. From this I could get like people know what is what, and apart from these we'll get to know how things are being in the session. Like we'll get to know a lot many topics, and I hope it's being very informative to all of you. Next slide. So in our today's discussion, our first speaker is Sujana Ramesh. She's currently working in John Deere, and she'll be discussing about embedded software. The floor is to you.
Can you hear me? Hi. Is there not interference?
Yeah, we can hear you.
Okay, great. Hi everyone, brief introduction. I completed my technical batch in 20, like I think she already mentioned, and I was an embedded software engineer at John Deere, and now I'll be moving over for my master's. Um, Embedded software, I think, just do a quick.
Uh,
Okay, we first we'll start with what is an embedded system. So everything around you is basically an embedded system. Any electronic item you see, most of it is an embedded system. Your phone, TV, laptop, AC, everything is an embedded system. So major thing here is there is hardware, and on top of that there are applications built which you can use. Applications are built on either microcontrollers or they are built within the system itself with RAM and ROM, and that makes a complete embedded system. So I think I will go ahead with the topmost layer, which is the application, like you can see in the picture. So hardware is the bottommost layer, and on top of that we have all the microcontroller and driver abstractions, and the topmost is the application layer. So I think I will be talking as an embedded software engineer. I'll be talking on the application layer, whereas I think firmware will dive deeper into it. So topmost is the application layer. Karthiha, can you do another click? Yeah. So what is embedded software? So to clear it up, it is not the applications you see on your phone. So that's not how embedded software works. So everyone knows that when you do start up your laptop, there is some operating system that starts up, right? Or say phone. We'll take the example of phone. So when your phone starts up, your Android boots up automatically. There are some functions in Android. Android is the OS, so that is a different thing altogether. So there are some functions in Android apart from the apps that you use that go into embedded software. Like say brightness adjustment. That is the best example of an embedded software. So it is something the user controls, but it is something that is pre-programmed into your device and it cannot be changed. Like in an app, things get changed, but whereas with brightness, it cannot be changed. It has been pre-programmed into the hardware itself. So that is embedded software. It is different from software. It is different from firmware. So it's the in-between layer, which is a specialized pre-programming that is done directly onto chips, which cannot be changed. And some examples. So can we have another clip? So I think the image is a little small. But okay. So some examples are there is an autofocus when you start the camera. That is an embedded software, which means you are technically controlling it, but the programming is already fixed. It cannot be changed ever by you. So that is an embedded software. Your washing machine, when you click on a button, what happens behind? The transfer of code from the click to what happens next is embedded software. The seconds you see on the display of a traffic control, that is an embedded software. Brightness on your phone is an embedded software. So with respect to what I work on a device that is similar to a touchscreen laptop set. It's an LCD display, which is touchscreen, and it has its own operating system. It doesn't have to work on anything else. So for that, we have. So I built applications on that display. Moving on to what, as freshers, you need to get into the industry. So embedded software is actually very popular industry. If you see any company coming up and telling you they are recruiting for embedded roles, it's either of two roles. One is embedded software, the other is firmware. And most of the companies which work currently on embedded software are automotive-based companies. Like John Deere is an agricultural automotive, so that works on embedded software. Then there are companies like Bosch and other car companies, Mercedes and Bentley. So they are major manufacturers of embedded software systems right now because they have their own electronic systems in the car. I think if you had ever studied mechanical based subjects, you will know that there is the car has an electrical system of its own. So most of that electrical system runs on embedded software code. So they use embedded software to maximum, from brakes, anti-lock brakes to the radio system. A lot of it uses embedded software. Some skill sets you need to develop to enter into the embedded software industry. So majority of the embedded software code takes place in C++. So that is definitely a skill worth having. So I personally worked on C++ and it helped me a lot in my projects because C++ is a language that easily we can read the hardware code and implement it in C++ in an easier way, which is why it is preferred by most companies. C++ is definitely a good start. Then there is embedded C programming, which I'm sure if you have worked with microcontrollers, you'll be slightly familiar with. So the higher level embedded C programming is used on embedded software codes. And MATLAB is used to design and power simulation purposes. So MATLAB is also very useful in embedded software. So if you have either of these skill sets, I think you are good to go for an embedded software role. Yeah, that's pretty much all I had. Are we taking questions now? Or?
Karthiha? We'll take the questions at the end.
Okay, cool. Thank you.
It was a very informative session, like right from knowing what is the embedded system and then having a closer look at the embedded software and then getting to know what is the skills needed. It was like, and people who doesn't have much idea, it was like very good informative session for them, and thank you for the session.
Thank you.
Next slide. So our next speaker is Bhavya Krishna, and she's currently working in Western Digital, and she'll be talking about firmware development.
Am I audible?
Yeah, you're audible, Bhavya.
Yeah, hi. Hi everyone. Firstly, thank you for giving me this opportunity. I'll hope to explain what I do at my work. And if you have any doubts, if you have any specific doubts regarding whatever I speak, you can ping me later after the session also. As Sujana has already explained, she's already defined and given you a bigger picture about what an embedded system is. Embedded software and firmware are pretty much interchangeable in most places. But from at least from my work experience over the last 2 years in Western Digital, I've been working on firmware development, which is closer to the hardware. Wherein, Western Digital is a company that. Can you go to the next slide? Yeah, so Western Digital or SanDisk as the brand, as most of you will be familiar with, comes up with products, data storage products. And I work in the Flash business unit. So all our products have been like pen drives and SD cards and SSDs. So my experience has been with how to make just a chip with memory and a controller into a product which can be just interfaced into your laptops or mobile phones and cameras to store your and perform your storage operations, basically writing, reading, and erasing files. So, uh, like my specification is mostly aimed at the storage architecture. So, like as Krishna said, one of the major users of firmware currently is automotive, and another similar application. Like there are multiple applications which use firmware like wearables. You see your digital watches and etc. And they storage is another field which needs the firmware layer. If we take any card, for example, say an SD card, it has to take in data from it has to have a USB interface to if you say SD, it will be SD protocol to take data from whatever if it's camera, the camera will have an SD interface. It has to take data from that, and it has to store it into the NAND flash memory. I'm sure you have learned about the NAND flash and how you have the gate, floating gate, and all that in your electronic courses. So there will be a memory, and but we have to transfer the data from the port to the device, and we have to have for this operation, it needs a lot of teams inside to take care of the various problems. Like so, hardware will have a lot of defects. There might be like over programming. A lot of defects will happen over time due to heating. So, but when we have to make the product a reliable one so that the customer who's using it doesn't lose data. So reliability is something that we need. Security to ensure that the data doesn't fall in the hands of a wrong person. To have some encryption. So a lot of these things, there will be multiple features for a product when you make it. Like there should be some. It should if it's an SD card, it should operate in little power that the phone can provide, right? So, but if it's an SSD, when you connect it to the laptop, it can draw in more power. So there will be power limitation. There will be a limit. There will be a requirement for a performance. We need to have security. We need to have reliability. So all of these features are implemented as multiple algorithms and schemes in the firmware, and this firmware will directly interface with the hardware, the controller, and the memory. So the memory, when I say it's just ROM basically. So the firmware is stored in the ROM, and it also manipulates how other user data can be stored in the NAND memory. And it like in day-to-day life, I interact my firmware interacts with the basic modules of what in the controller. Say in the computer architecture, you learned about DMA or memory management or buffers, ADM. All these modules need to be given. They need to be configured. They need to be turned on and off and supplied with data. So all of these modules that you learn in computer architecture, all of these hardware modules are or even if you take a simple register, right? So the register needs to be the register has to have data written onto it for doing a particular operation. So firmware is the one that writes the data to that. So and What we use is a real-time operating system and we have multiple threads because we need to have parallel operations happening. And this is something that is used like in general in multiple firmware, like in multiple products across different companies. Our real-time operating system is something that is a generic platform used. So one of the major things, like if I would say like constitutes like firmware development, we need to manage the various tasks, and we have to coordinate to ensure that all the tasks are happening parallelly to improve the performance. At the same time, the flow of the process should not be disrupted because of not being in coordination or something. And yeah, so we'll go to the next slide. So the projects that I was part of, that I would like to mention here is that, so for NAND flash we have like one might like I used to question myself, like pen drives are already there, SD cards are already there. What are people working on right now again and again? But something that we sometimes tend to not notice is that in the same form factor of an SD card or a pen drive, earlier we used to have 16 GB, 32 GB. Now we have 1 TB in this much size of an SD card. So this is happening because of the innovation in the memory size, where in the physical region they stack up more and more layers of the memory. So to make this increased like capacity in the same size, there'll be more hardware defects that are possible and more use cases and scenarios. So firmware will also keep updating to make sure that this we are able to get more and more capacity with the same power and same size of the earlier generation. So I was part of the 172 layer sixth generation, that is a limited edition release for the first time ever. So I was part of that project. And second thing is, so just like when we say, right, so Sujana was talking about how they have an LCD monitor and cameras and everything. So these cameras use SD cards for storing their video surveillance. So though we make generic products also, Western Digital customizes their SD cards for specific users because it might require that some Canon camera needs this much performance of a video recording, or it cannot go beyond this much power level. So we customize our products for certain users because their use cases are different. So there was this thing where car dash camera, we had to customize our SD card to meet their requirements. And there was one time I got to actually, talk to the customers. I mean, the customers again are business only, not exactly users, but what kind of requirements they have. So what changes can we make in our architecture to meet those requirements? So that was something that I got a bigger picture. But mostly I worked with the drivers and memory management and internal to the computer architecture. So skills expected, as Sujana mentioned again, is mostly C++ and C. And assembly language is something that keeps coming sometimes to make sure that your code is very efficient. And sometimes we'll be using these primitive controllers, and there won't be compilers for them, so we have to code in assembly language. That is something. And yeah, another like technical skills knowledge that will be needed is in computer architecture and real-time operating systems. And Python and other scripting languages will also be helpful because these are the skills that are mainly used for testing our firmware. And yeah, and simulation software like MATLAB will also come in handy. Based on your project, it might be required. But mostly, if you know these basic skills like C, C++, assembly language, computer architecture, and auto, you should be good to go for applying to a firmware development role. Yeah, I think that's it.
Thank you, Bhavya. It was very informative session. Like we got an overview of memory, and we got to know how firmware is, and like how your work experience was with respect to the firmware, and what are the skills required also. Thank you so much. Uh, Now we'll be doing a small ice breaking activity. So you can go to medi.com and enter the code, or we'll send the link in the chat box. It is just a small short quiz. Guys, the link is shared in the chat box. I would request all the mentees and the other attendees to take this small activity. So the storage of firmware is done in, like, we could see like majority going with ROM, and yep, it is actually like the storage is done in ROM. And next question. Guys, I would request to fill out this question too. I could see few examples coming out, like IoT devices, sensors, smartwatches. Yep, guys, it's like I could see a lot many things. It's like so many examples are there which are related to embedded systems. We use embedded systems in various applications, and it's good to see like you guys have listed out a lot many applications. I guess everyone have filled it up. So now, yeah, we'll move on to the next discussion. Yeah, so our next set of speakers, Amritha. She's currently working in NVIDIA and she'll be like discussing on the topic of electronics and ASIC development. Over to you, Amritha.
Yeah. Hi everyone. I hope I'm audible.
Yeah,
Yeah.
Amritha, you're audible.
Yeah, thank you. So thanks for this opportunity. So I graduated in 2020 and currently I'm working in NVIDIA front end verification and design. So yeah, so I'll talk about ASIC development in a brief. Can you go to the next slide? Yeah, so as the name itself suggests, ASIC stands for Application Specific Integrated Chip, in which we design a chip for a specific purpose. So in industries, there is a large scale of work that development that goes behind a chip. So here I have listed down the different sectors that get involved. So first one, namely a system level design, in which you actually draft your requirements of the chip, try to create a micro architecture of the chip so that you can create a specification level that can be used in creating a hardware. And next is the front end design. So I think front end design, back end design is majorly the common terms that people would have heard of when it comes to ASIC development. So in front end, what we do is, so now we have a specification, we have a skeleton. So now we have to code this specification into RTL. So we use hardware description languages such as Verilog, VHDL, and System Verilog to create this system level specification into a RTL, that is register transfer level logic. That's what happens in the first step. And the next step is functional verification. So now we have a specification. So there is an entire team that will start developing a stimulus for to check all the functionality that is specified in the specification. So even though everything here seems to be sequential, but most of the stuff in industries happen in parallel. That is, the functional verification team will start making its stimulus right at the time when the design team is actually starting to build on its RTL. So yeah, so first step is RTL design, and then there's a functional verification team that is going to verify your logic. And there is some more things like logic synthesis. So what happens is, what we code is an RTL, which will be developed into a netlist. So netlist will basically be your OR and NAND NOR gates. So RTL will be a bit of a higher language. So first thing is, your logic has to be synthesizable. That is, whatever you have coded should be able to be translated into a much primitive and or logic. So there is one team that just checks if the logic is synthesizable, and also there are other verification parameters that comes under this. For example, you would have learned about static timing analysis, and then there will be clock domain crossing issues, reset domain crossing issues. So there are a lot of synthesis verification that has to happen to the RTL that we have coded. So all of this falls under front-end design. So, and then there is the next step, which is the back-end design. So what they do in back-end design is, they will take snaps of your netlist and they decide on where each different block has to go in the chip. So there is floor planning, which will basically be like where the specific. So if you consider a system on chip, right? In a system on chip, there will be a CPU, there will be GPUs, there will be other set of microcontrollers that will be aiding all the input output. So in floor planning, the first step the floor planning people will do is where each controller has to come, so that there will be less of power dissipation and better area usage. So that so a backend design will be floor planning and placement and routing. So you just place all these blocks in the where it has to come in the chip, and then you have to tape out. So I am majorly in front end design, so I may not know much technicalities in backend design. So, and then there are other set of teams also which work on test circuit insertion. So, so now after backend design, we do a tape out. Tape out is basically you give this physically designed physically designed unit to a fabrication unit like TSMC and so on, where they fabricate it into a chip. So after this chip is fabricated, there is an entire round of post-silicon validation in which you have to do a lot of tests like DFT. Using the design for testability, you will test all the registers. You will test. There is also built-in tests, right? So you will do all that built-in tests. So your logic should also. There is a team that works in inserting this logic in the circuit. So this DFT and all of it should be included before it goes. So there is one more team that works on it. So that's the overall flow of ASIC development. And regarding my experience, I have been working in, I have worked in verification and design of a USB controller. So this controller basically talks with the CPU and with the memory, and it is a direct memory access controller as well. So it talks with the CPU and with the memory and with the device that is connected to it. So, and I worked on USB protocol of it. So as you can see, there are different layers. So the controller that I had worked was capable of implementing all three: protocol, link, and physical layer. And the CPU level software will be the functional layer that communicates with this controller to the external level. And in the left, I have added a picture of verification, how how a design is verified. So yeah, so this is the overall DUT will be your design unit. You'll create all these other small modules so that you can create stimulus that can talk to the duct. So yeah, basically that's it. And the skill set required for for design, front-end design, the skill set basically will be logic design, system Verilog and Verilog. So for a fresher, logic design will be a must, but system Verilog you can develop as you work on it. So, and for verification, so most of the verification is done in UVM in most of the companies. UVM is the latest universal verification methodology. So UVM is basically, it's like a library that extensively uses OOPS concept. So OOPS is very important for verification, and a basic idea of how a test bench architecture will also be required. And along with this, a lot of scripting languages is also used to create automation in design and verification. So Shell, Perl, or Python scripting knowledge will also be helpful. It's not a must, but it will be helpful. So yeah, that's my presentation.
Thank you, Amritha. It was very insightful session, like getting an overview of how the ASIC development works. So before moving on to the next speaker, we'll have a small Q&A session now, and we'll share the link in the chat box. Guys, the link is being shared in the chat box. I could see a few questions coming up. So the first question is how to prepare for an online test for electronics company.
Uh,
I would like Amritha and Bhavya and Sujana to answer this question.
Do you want to start?
Uh, yeah, so it is important that you're thorough with FSM logics, SPA, and normal combinational circuits as well, because most of the OTs that I had attended had majorly on FSMs and SPAs and combinational circuits. In interviews, they might drill you more on the how you think and how you can the architecture, computer architecture point of view. But for online test, it's important that you are thorough with the basic digital design.
I see a follow up on what is FSM. So FSM here is finite state machine, and there is a concept of creating uh, an entire system digitally. So that if you, I think you'll find a lot of resources on YouTube, as well as you'll have it as a part of your course if you're into electronics, if you're in the electronics department. Yeah. And as for online test is concerned, I think aptitude also plays a major role in electronics online tests. So it will be good to prepare well with aptitude, because that can get you the over the cutoff. Yeah, Bhavya, you want to add anything?
yeah, finite state machines, if you join digital electronics, basically you draw all the state diagrams, you draw bubbles, arrows from 101, you assign the state diagrams and all. That is what finite state machines. Uh, I see, yeah, I see this as a complete beginner start any of this. It seems too complicated. I would say most of our knowledge was gained mostly after college in these 3 years of experience. Whatever we spoke was mainly we got a clarity after we got into the jobs. But to get into these jobs, you need basic knowledge only. Mostly it can be that is part of the courses. There is no need to get overwhelmed or anything. All of us are available for any time for any clarifications. Get your fundamentals right from like very clear from whatever you learn from the courses we have, right? Computer architecture, digital electronics, all of these like get a get your basics clarified and you can acquire skills on top. There are multiple sources online also. And there's a question, what is RTOS? Can I just take that, Karthiha?
Yeah, sure.
Yeah, so that is basically RTOS is real-time operating system. So you have multiple operating systems, right? You know about Linux, Ubuntu, Windows, or so Unix for Mac and etc. So real-time operating system is an operating system basically, wherein the real-time as it states, basically its aim is not to have a great performance for any complex task to do. The main idea is to what to say, basically act on any signal in limited constraints. So if say you are having driving a car, it has an RTOS, and you are having some automatic driving algorithm that is running. But if an accident happens, the airbag should open within like some milliseconds or so, right? To ensure safety of the passenger. So even it's okay to compromise on the performance of the usual task as long as you're able to react and respond to any signal in a specified amount of time. So that's the major constraint on a real-time operating system compared to the generic operating systems like Windows or Linux, and that is what is used in most embedded systems.
Uh, it was very good. I hope people would have got clarity on what RTOS is and how to prepare for online tests for the company. And the next question is to Sujana. What are the courses that a fresher need to start with the embedded systems learning?
Okay, so there are no courses as such that I did or I'm familiar with actually. So one thing you can do is work on your C++ skills. So C++ has evolved a lot, and this was something again, like Bhavya said, I learned most of this after I finished college. But if you do get some time in college, one thing that would help is improving your C++ knowledge, and the way you program. That will help a lot if you're looking to get it at the boards. And there might be some electives for the circuitral branches on embedded systems, which might or might not help. I did an elective too, but okay, had very basic things about embedded systems. But it might look good on a transcript when you go for interviews. And apart from that, just work on your C, C++ skills and basics of electronics. Keep the basics of electronics completely thorough and work on C, C++ skills, and you should be good for embedded systems. It would help if you do an internship. So if you have an internship in embedded systems, that will help you.
Guys, since there are a lot many questions, we'll come back to we'll get the other questions answered after the next session, next set of speakers speak. So our next topic is on 5G systems. It's going to be a talk given by Madhavi Ravanan, who's currently working in Nokia. Over to you.
Hi, thank you, Karthiha. So nice meeting all of you. And yeah, I lead the customer engineering delivery unit in Nokia. This is within the core networks business unit, which is part of cloud and network services business group in Nokia. Right? Now, the topic is about 5G systems. I assume those of you who are students are probably in the between the first and third year, or some of you may be intermediate. So, what really is the work involved? I mean, if you look at 5G as a overall concept, there is truckload of business, right? 5G services market is anticipated to be growing at a 40+% rate, and it's already at global market is like 64 billion today, and imagine 40% CAGR, compounded annual growth rate. Then imagine the volume of work involved, in delivering 5G services to let's say businesses and retail users like all of us, to industries and enterprises and so on. So what really goes into 5G networks? I will focus just on 5G networks because that is the space that I work in. If you talk about generic 5G, there are a truckload of other areas of work that happens on applications, that happens on customer support, and so on. But we'll focus just on the R&D side of things, right? What really, let's say, a company like Nokia or any other competitor in the networking infrastructure space does in 5G as an area. That's what we'll look at. Karthiha, can you scroll the slide down? Okay, so the font is quite small. So let's say Nokia builds hardware and software that can create the 5G network itself. I'm sure many of you may be familiar with mobile communication networks, right? There's a radio access network that provides the radio connectivity for subscriber equipment or user equipment, as we call it. And then there is a core network that handles the traffic and then switches between different endpoint access networks, right? So if you look at a company like Nokia, we build all of the software. I'm sure some of you may be reading the networking architectures that 3GPP, third generation partnership project, which defines the different generation of network architecture. You would have seen the overall architecture of a 5G network. Very simply put, there's a radio access network and then there is a core network, right? In core network, there are multitude of networking appliances that are required to enable the flow of traffic. Imagine the traffic speed in 5G. I'm not able to recall the exact throughput numbers and so on. If, let's say, video traffic, voice traffic, all the IoT sensor traffic has to be carried through the network, then we are talking about extremely high speed routers and switches and associated, let's say, subscriber information processing equipment, equipment that can process voice calls, equipment that can process internet traffic and so on, right? So all of these appliances run on what we call as a telco cloud. If you go back in time, maybe 10, 15 years ago, every one of these appliances were sitting in operators network. And if we have to take an example, operators in India, if you think of, let's say, Bharti Airtel and Vodafone Idea and BSNL, if you go into their exchanges, you will get to see the sort of infrastructure that these operators have to have. It's not just the radio. When you go on a highway, you'll get to see the radio equipment, right? So the radio equipment connects to the base station, and then there's a core network that sits in operators' data centers. So let's say until 10 years ago, each of the functions in the PGPP architecture would have been a dedicated hardware appliance too. That's how the network was. Then virtualization happened, just like how in generic computing you all take VM capacity from Amazon and you go on to do the programming, right? You don't have to buy a computer yourself, I mean, buy additional computing power yourself. You can just spin off instances from AWS. So same way, we virtualized the network functions, which meant all the dedicated hardware could go away. So we created what's called as telco cloud, which is infrastructure as a service, somewhat of an equivalent of AWS for telco applications. I think there was a good question on what is a real-time operating system. If you think of, let's say, all the software that is involved in processing your voice calls, that could be an example of a real-time system, because you don't want it that I speak and you don't hear it at the same moment, right? Let's say in data traffic, it's okay. I text you and there is a second delay between me sending and me receiving is okay, but not in a voice call or on a video call. So coming back, so we evolved into what is called as telco cloud, and then these clouds would host network functions, different network functions. So that did away with dedicated hardware appliances that were needed in the network. So everything became general purpose servers, and software runs on these servers, right? Now the next evolution that's happening in the network is what we call as cloud native architecture evolution. So in this case, we are doing away with on-prem cloud, and mostly whichever operator is more open and willing. You might have, I mean, in the US there's this operator by name Dish, which launched the entire 5G network on AWS cloud. So the advantage is the operator need not buy stuff, buy loads of stuff, put into their data center, pay the electricity bill, power bill, cooling bill, and employ people to monitor, etc. Right? They can get the capacity from a public cloud provider. In their case, it was AWS, and we have moved the virtual network functions, which used to run on what's called as telco cloud, which is an equivalent of, let's say, VMware's whatever, I think VBox or something is server virtualization, right? You extrapolate that to a data center rack, then that's what we call as telco cloud. It has compute, networking, and storage all assembled into, let's say, one rack, right? Now, in the next evolution, we are moving the software to even public cloud, to operators for billing. So this is one example of an evolution. While this is one, other evolution that's happening in the 5G network is so far operator networks need to be super secure, right? Your connectivity infrastructure can never be compromised. So everybody had their own in-house infra, in-house software, and very tight security. Now, with, let's say, IT applications having moved the SaaS way, operators are also looking at taking networking software as service, which means if I am a new operator and I want to get into 5G services business like Bhavya, Airtel, or Vodafone Idea, I am the third operator who has the aspiration to do that. I could buy the license, and I can just take all the network software as a service. I don't have to build, I don't have to deploy, I don't have to run, I don't have to monitor, I don't have to pay. I just I buy subscription of all of the software. I mean, it may sound very simple, but there is loads and loads of complexities in building a network. These run as yearly projects, right? Just taking products from R&D and setting up a 5G network for an operator can take a whole year today, right? So the evolution, one evolution is moving the network itself to public cloud. Second evolution is moving away from dedicated instances of the software to software as a service. Right? These are two. So when we do these two, what's also happening is the cloud native architecture evolution, which means software traditionally for operator networks had been built as monolithic software. Now this is all becoming microservices based, and that is the evolution, which will run on Kubernetes or equivalent of Kubernetes distributions from commercial vendors. Nokia has its own Kubernetes distribution too. So this is the evolution. Now, okay, coming to what sort of projects I do and what overall, what is the traction overall in the industry? As 3GPP comes up with newer releases of network specification, then every telecom software vendor has to upgrade their products. I mean, create or upgrade. When 5G was launched, it became a new set of network functions that had to be architected, designed, developed, and rolled out to operators. In incremental releases, we will have to achieve release compliance because every let's say network equipment provider world over has to comply with these standards because operators will need to comply with the standards. So as the standards evolve, the products would also evolve, right? So the nature of work involved is you would be building software that meets the specification releases defined by standards like 3GPP or the European telecom standard HC association, and there are some country specific standards too, right? So this is the nature of work involved, software development. And then there are times when, let's say, when we moved from dedicated appliances to virtual network functions, it became complete re-architecting. And now as we move to 5G, most of the products are getting totally re-architected. So which means you dump the, I mean, where feasible, you dump the legacy, you draw a common architecture, you build scalable solutions. That is what is happening. So eventually it is your ability to understand a specification and translate it into products that are built in a scalable, sustainable manner, right? Skills for an entry level engineer, like most of you said, I think the actual learning happens after you enter the workforce. So for an entry level engineer, of course, we just look for programming skills, and if any of you, if you are from a branch that includes communication networks as an area, then we look for how strong the candidate is on the basics, and we go from there. So programming skills, we primarily, most of our products are developed using C++, some in Java, and some of the tooling is developed using Python. So long as the candidate is strong in one of the C, C++ or Java and Python as an add-on, then that's what it is. So this is on the engineering side. Of course, for those of you with aspirations going into, let's say, product management, portfolio management, and so on, so that's another line of entry. But I don't think we've taken fresh engineers into those lines. But after gaining a few years of experience, you can aspire to get in there. Right side is a picture. If you go into an operator's facility exchange, then you're likely to see volumes of racks of server equipment today, which means they have an on-prem cloud which hosts their software that runs the network. So this is all real-time software, right? Not generic, let's say, IT or retail user software. So that's a wee bit. I'm happy to take questions. You can post whenever there is a window to that. Yeah, over to you.
Uh, Thank you, Madhavi. It was
Yeah.
another insightful session, like where we got to know about how the 5G network is, how things are happening in Nokia too. Thank you so much.
Welcome.
Moving on, we'll have a Q&A after the last speaker. So before going to the last topic of today's session, we have another short icebreaker activity. Guys, we'll come back to the Q&A after the last session. We'll answer the questions that has been unanswered yet, and the floor is open to the other set of questions too. Guys, the link is being shared in the chat box. Divya, whether the link is being shared?
Yeah, the link is shared. Oh, sorry.
Yeah, like we got the link. Guys, the link is in the chat box. Yep, we could see the terms getting, like, the list of terms getting arranged, like. So yeah, like actually the order is specification, logic design, logic synthesis, and physical design are the actual orders. And the next question. Guys, this is, here there are three statements, and select the odd and out statement with related to 5G networks. So we could see responses coming in. Yeah, so actually till now, like 5G doesn't allow teleportation yet, but compared to the other networks, 5G has a lower latency and 5G is actually more secure. I guess like here comes the end of the activity, and we'll move on to the next topic, that is on power systems. It's by Angela. She's currently working in Power Grid Corporation of India Limited. Over to you.
Thank you, Karthiha. Good morning, all of you. It's lovely meeting all of you and having a discussion right here. So as Karthiha has already introduced, I'm Angela and I've been working with Power Grid Corporation of India Limited for the past 12 years. And there is a slight correction. I'm not from the electrical batch, I'm from the electronics and communication batch. So Karthiha, if you can move on to the next slide.
Yeah.
Okay, so I'll give you an overview of the power systems and the power utility industry as such. So power system consists of all the electrical networks or the components that is there up till the consumer side, from the generation of electricity, the transmission of electricity, the distribution of electricity, and how it reaches the end consumers, the industrial consumers, the agricultural consumers, and also the home consumers like us. So if you look at the portfolio of jobs you can apply for in the power utility, you have different domains, main domains. I am in the transmission sector. Power Grid Corporation is the main transmission utility of India. So I just go through the various companies that are available in the various domains of power systems. Okay. So first is generation, that is where the electricity is generated. So it can be thermal generation, nuclear generation, hydro, renewables. So we have a lot of industries in India like NTPC, NHPC, DVC. Then if you go abroad, you have Orsted, EDF, etc. Next, in the transmission sector, that is where the electricity gets transmitted from the generation up till the distribution sector. So that consists of transmission lines, the photo besides it, that's the transmission line. Okay, so there is transmission lines, there are substations. So all these infrastructure is developed and maintained by utilities like Power Grid. Then there is also private entities like Adani, Sterlite. If you go abroad, you can have a National Grid of UK, SSEN in Scotland, SGC in China, Hydro Global Canada, etc. Then if we come to distribution, again distribution, we might be knowing all the bills that we get for our electricity. We pay to the distribution utilities. So for example, Bescom in Bangalore, Gujarat Bridge Company in Gujarat, MSCDCL of Maharashtra, Tata, TTPDL in Delhi, etc. So these are the main utility industries: transmission, generation, and distribution. Apart from these, if you want to have a career in research and development with respect to power system, again there are industries, R&D centers like CPRI, the Central Power Research Institute in Bangalore. Then there is the ELTA, NPTI, National Power Training Institute, etc. Apart from all these, we also have consultants, regulatory bodies, and other vendors who actually bring in a lot of technologies here. So the previous speakers who were present in this room, most of them have described about embedded systems, firmware, then about application technologies, etc. And all these are brought in here. So there are companies like Hitachi, the erstwhile ABB, Siemens, GE, Atkins, all of these, they bring in equipments like relays, which have all these, which utilizes all the embedded system, firmware technologies, etc. Then there are EPC infrastructure contractors like L&T, KEC. Then there is regulatory bodies like CEA, Central Electricity Authority, POSOCO, then energy exchanges, etc. So these are the main companies, most companies that are available in the power system and the power utility sector. The reason why power utility is not a most desired, career opportunity is because most of the utilities in the power sector, they are under the government. So all of us, we go to the Ministry of Power, Generation, Distribution and Transmission. We report to the Ministry of Power, and the renewable industries, they report into the Ministry of Renewable Energy. And if we say the industry and the utilities as such, we are working for the power sector, normal people. So our agenda as such of generation and transmission and distribution utilities is to have power for all in India. Alright. So if we can move on to the next slide, Karthiha. Yes, so now we'll go on to my experience and the future of the power utility industry. So first, I'll tell you, as I have already informed, I've worked for nearly 12 years in this power grid as, at different levels and with different spheres. I am actually an electronics and communication graduate, so which means being working in electrical company, power grid is an electricity transmission company. So my job is mostly a cross-functional job. I started off as an engineer, and I have been working as manager, and now I'm at chief manager level at the corporate center in Gurgaon right now. So if we say the main aspect of transmission company, if we say there is transmission lines and there are substations. So these are huge infrastructures which are built and operated by these utilities. So whenever you're traveling across roads, you can see a lot of towers and lines crossing by. All these lines, they terminate in a place called as a substation. So managing these substations, constructing these substations, that is the main work of a transmission utility. Whereas in a generation utility, if you see, it is construction and management of a generating plant and associated systems. So these technical terms might be highly technical for all of you, so I'm not going into these. My experience has been in gas in field for substations, asset management of substations, and engineering of communication system. If you have any doubts in this, we can probably discuss in the next few slides or probably during the Q&A session. Now, when we talk about the future of power utility industry, so power, as we all know, is one of the basic life requirement, power and electricity. So there is this industry is not going to die, and it will need to grow because of a lot of focus on renewable energy and because you want to ask something. Okay. Yes. So moving on. Now we were talking about, yes, the future of our utility industry. Talking about it, the power and electricity is the basic requirement. Power and electricity is the basic life requirement, and there is a lot of thrust on renewable energy and climate action. After the COP26, all of you might have read in the newspaper that there was this COP26 climate action plan, and India has a really huge, target. In 2030, we have to meet 100 to 500 gigawatts of renewable energy, and right now in 2022, we are standing at 136. So there's a lot of gaps which is needed to be filled, and there's a lot of job opportunity which is going to come up in that time. Then there is a lot of thrust on renewable energy. There is a lot of innovation that is going on in energy storage, electric vehicles, renewable energy, offshore wind farms, subsea transmission. All of these are highly technical. I don't think any of you is going to understand, but just to have an awareness of from this end. Karthiha, if you can go on to the last slide. Yeah, so now coming to the skills and qualifications. So in many of the other career opportunities that we talk about today, most of it requires you to have C, C++ kind of skills. Whereas for work in career in power utility industry, most of what we need is to be learned in the industry as such. So what we learn in college, it is going to be the fundamentals, but you have to have the application-wise knowledge, which you will gain only with experience after joining the industry. So as such, the skills required is just general basic life skills like teams, being a good team player, good problem solving ability, and having just a good attitude and things like that. But if we talk about qualifications, I have listed out in two categories. One is for qualifications within India, and one is if you're looking for jobs abroad in power utility industry, right? So in India, mostly all the power utility industry, they take graduates from electrical and electronics. And since most of the power utility industries, they are, PSUs, that is public sector undertakings, most of the institutes are GATE exams. So if you are anyways preparing for GATE and you get a good score, you can as such apply for these utilities. Next, there is specialized intakes also for all the cross-functional works, like so for example, mechanical, civil, IT, etc. So these are specialized posts, not catering to the main field of job in the utility industry, but other jobs. Then, if we see the main difference between Indian and international power utilities is that in India, mostly all the job portfolios are handled by engineers. The engineers, once they reach a specific level of experience, like say 10, 15 years of experience, then they become managers, middle managers, senior level managers. For international utilities, there's a specific requirement. They have to have MBA skills, so they have to have strategy related qualifications, which they have to be in senior level positions. So if we see international job portfolios, we have a lot of companies where you can apply for, but as a graduate engineer, the intakes are really rare. You have to have some kind of qualification from that country so that you can apply for a job. So it will be most useful if you can go for an MS in that particular country where you want to apply for, and then pursue a job. But please make sure that you have relevant industry experience before you go for any such specialized courses, because otherwise it's going to be a really tiring job to extend your visa, get another visa extension, right? So just a few of the specialized courses that is available abroad is renewable sustainable energy, energy and power system engineering, energy management, subsea engineering, etc. Okay, and in international, as I said, only the engineering portfolios is being managed by the engineers, and the balance portfolio in the utility industry will be managed by a specific skill set, people with specific skill set like a data analysis only will handle analysis, only a person with project management or MBA can handle the project management, only a person with business and strategy specialization in MBA, they can be a strategy lead, etc. So if you go for international, be sure to have some kind of a utility experience within India and then go for a specialization course and continue to work abroad. Or if you want to have in India, the best choice is to have a good grade score and then apply for it. So if you have any questions on this, you can put it up in the Q&A session. So thank you, and back to you, Karthiha.
Thank you, Angela. It was actually an enlightening session on this topic. So now we are back to the Q&A. Guys, the link has already been shared. We'll also share it again. Among these questions, we have actually few questions have been already answered. So I'll come back to the questions which are left unanswered. The question is to Bhavya. Can you give a brief idea about the computer architecture?
That's a whole course that we have in undergraduate usually. Hello.
Yeah, you're audible, Bhavya.
Yeah, computer architecture is a whole course in undergraduate. So basically, we learn about the different modules inside a computing device. Like you have an arithmetic logical unit, or you have a memory DMA unit, and you have registers and control unit and timing unit. So it's a whole course, and there are multiple. I would say Mazidi is a good book to learn computer architecture. Yeah, and there are multiple books. If anyone needs more resources on it, you can ping me and I can look them up properly. And I can't recollect on the top of my mind. So it's a whole course. It's a very interesting course, and yeah, you can look into it.
Thank you, Bhavya. So the next question is actually what is assembly language? Bhavya, can you give your inputs on this?
Assembly language is basically it's just like when I think in basic computer science you have learned it. You have high level languages, assembly languages, and then machine language. Assembly language comes in between machine language and high level languages, where you have small, simple operations like jump and checking inequality and stuff. You don't have the for loops or while loops or all those functions, and those things are not there. But it's slightly above the machine language. Mostly we code in assembly language in the undergraduate courses for microprocessors, microcontrollers in the labs, etc. 8085 and all. There we use assembly language. We have jumping, reading registers, and loading a value from a memory, etc. Only primitive operations will be there. It's between high level and machine language.
Thank you, Bhavya. So the next question is what projects we can take up to.
Karthiha, you're on mute.
Oh, sorry. So the next question is what projects we can take up to learn more about electronics domain. I would like Amritha and Madhavi to answer on this.
Yeah, projects in the electronics domain, probably you mean some work closer to chipsets and boards and things like that. So maybe you should just look up companies that do such work in India. I may not be able to guide you in a great way on this theme. I know Intel does a lot of its R&D work here, and some of the companies that the fellow presenters covered here could be potential targets. See, I can tell you how we take interns in Nokia. The way we approach it, we select certain universities and we select interns. We offer internships ranging from, actually, I personally prefer 6-month internships because for bachelors we can't get 6 months duration. We typically take master students in their final semester. We observe their performance for 6 months and then we give a full-time offer, right? That's the practice we have brought in last 1-2 years. So every company might have a empaneled set of universities. So I'm sure NIT Trichy is part of empanelling those institutes in some of those companies. Best to work through your placement department, your respective department placement contacts, and figure out which are those companies, and just approach alumni in those companies, right? So they can tell you the internals. So for Nokia, there are a set of universities that you visit and take interns from, and then they convert it into full-time offers. Of course, there are challenges. Not for all interns we will be able to convert. It will depend on how many full-time positions get created, and hence how many of the interns meet the criteria. And there is always a delta. There are people whom we would like to absorb into full-time positions, and we may not be able to at that point in time. But then there are always positions opening up, and we just need to keep in touch with the people there. If you're particularly passionate about a specific line of work, then just reach out to alumni in those companies and ask them to guide you on specifics. That's what I'm able to say. I hope that's of some help.
Thank you, Madhavi. Amritha, could you give your inputs on this?
Yeah, sure. So, if you're looking for front-end design type of role, then there are a lot of online courses that are available. As Madhavi said, you can try for internships in the electronics companies, which will surely give you a very good insight in just 2 months. I mean, 2 months of internship will give a very good insight. But if not, then you can try taking up design projects, and there are a lot of available. I'll put one link in the chat box, which I used when I was in third year. So in this, they basically develop a CPU for running Tetris. Like you start from the smallest OR and code and create a CPU for Tetris. So there are a lot of courses of this sort that's available that you can try doing in your free time, just to know how the hardware coding is and how you can test your code as well by giving different inputs. So you can try that.
Thank you, Amita. The next question is, how does a complete beginner start any of this? It seems too complicated. I would like Sujana to answer on this.
Okay, yeah, it is, I think, very overwhelming in the beginning. But first thing is to just be clear on what you want. Like, see if you can get an idea with whatever subjects you take, which ones are interesting to you. And you can look up courses online. You can approach professors for any projects if they have, and you can look for internships in that area. And as you go over each stage, you learn something a little bit new, and then you work on it. That's how you develop. To be honest, I did most of the development after fresh college. And at any point, if you need any help with finding projects, or any technical advice or anything, you can always feel free to contact any of us. I think I for one am active on all my social medias, so you can ping me on LinkedIn, Insta, anything, and I will respond. So yeah, it's just go with the flow. Don't think too much into it. Just make a start. You'll always find out where to go. The starting is the hardest.
Thank you, Sujana. I would like to get inputs from other panelists too on this topic. I mean on this question.
One thing I think I would like to say is 3 years ago, when I was in third year, I honestly didn't have a great idea about any of these fields. I just knew about firmware and I got into that, and I started liking it over time. So any beginner in from college, we just get a taste of most of the courses. So everybody, all of us started at the same time, age actually. If you, I know Amritha and Sujana from college, we were classmates actually. So all of us started with very limited knowledge when we were second year, and over time in college, you are talking to your batchmates, seniors, getting resources and learning on your own. All of this helps, and I think as this whole platform really, what I would like to say is, what you can think is, if we who are just 2 3 years senior to you can do this, you can surely reach these, because we have gone through the same steps, so we are here to guide you. So it's not at all too complicated. It's very simple. It's doable. I think if we have done it, it's doable for you guys also. That's what I would like to say.
Thank you, Bhavya. Can you scroll down, Divya? Like, okay. So the next question is how to get intern or projects at foreign university. Uh, Sujana, can you give some inputs on this?
Yes, okay. I personally never did a foreign internship, but yeah, I have some basic idea I can give. So first thing, so there are programs like DAS and MyTax, which a lot of people in my batch had gone through and received it. I think if you talk to your immediate seniors, you might get to know the current process to get into those programs better. I'm not familiar with what it is right now. Um, and for other universities, mostly how we get any research internship is by mailing to professors. We go to website. If you go to the websites for any university that you are interested in, go to the website, look through the professors list, see, go through their works, their research, their area of interest, and their research works. Read through it, see which one is interesting to you, and you have to write a nice email. Not a standard template, but you can use a standard template, but make sure it has something personal as well. Write a nice email and email it to the professors. But you can't also tell you that it's a huge process, and you cannot expect a response every time. But sure, if you keep trying, you will definitely get a few responses, and from there you'll know what to do. So they'll tell you the next steps. If they're offering you an internship. So yeah, just don't get demotivated in the beginning. Keep trying, and I'm sure you'll land an intern if you do that. So majorly just emailing and getting. That's the best way to find internships.
Thank you, Sujana. So the next question is, what are the important concepts to learn in power systems to get industry experience? I would like Angela to answer on this.
Yes, so Chris, to learn in power system, there is no specific as far as I know. There is nothing which is taught in the college. It is, useful for the industry as such, because the utility work what we are doing is different from what we are learning. What we are learning in BTech is basic engineering, which is, the creation side of it, like, what is it, the create at the back end. But what happens in the industry is the application of what is already created. So I don't think there's any specific points to be learned, but in the interview, they will definitely ask you for doing basically application. They might even ask as simple a question like, what is the third, hole in the plug for? So unless you know what they are writing in an intro, you won't be able to understand. So having the fundamentals clear is what is most important than learning something in addition to what you are already learning in BTech. So I think that is more important here.
Thank you, Angela. The next question is, world is going towards 5G. What is the future vision for the network systems?
Yeah, yeah. Thanks, Karthiha. Yeah, I'll take that. So, future vision for network systems, like I said, there are a number of trends that are sweeping the telco industry. I mean, traditionally, telcos had their own exclusive area of play, right? Today, if you see, what I mean by that is there will only be another communication service provider who would compete with an existing communication provider, right? Service provider. But today, if you see companies, web scale companies like AWS, even Microsoft is trying to get into telecom space. They have made some acquisitions, and they are probably going to launch enterprise core network as a service is the news, right? Similarly, AWS has its own 5G offering. Now, traditional telco players, this is a what to say, this, we can see it either as healthy competition or it's a huge threat for traditional telecom players. So what's happening to telecom players is they're trying to be as or equally aggressive as possible in comparison with web scalers. So in doing so, the practices on how telcos build software and roll out and launch services is the pace or cycle time is reducing. If you have to think of a comparison, I think an application, a Gmail app would get updated maybe multiple times in a day, right? So Google's DevOps practices are much short. Plus, the applications are also relatively simpler. These are not networking applications, networking software, right? Now, if you compare that with telco space, you will see the product releases are easily spaced out by at least a couple of months. So, telco software engineering and rollout, build and rollout practices are adapting to the DevOps mode of working. Of course, that journey is already underway, and probably we are nearing maturity. But trying to get telecom software to the level of the fluidity that generic IT software is at, that is one theme that is playing out in the market, because now the strong boundary between that existed once between telecom players and IT players is nearly it's getting diluted, more and more diluted. So number one, so software is evolving and it has to become as fluid as generic IT software is. Only then the industry can, or telco players can compete with web scalers, right? So that is number one. Telco players have their own strengths. They have the strongest of the products, but IT players have, what to say, the most advanced software practices. So this is one theme. Now, as at a network level, of course, 3GPP keeps looking at what is the future for the network, right? So that way, already there is a 5G advanced definition, and then there is a 6G as well. So the standards are evolving. These standard bodies are again comprised by representatives from different companies who have a play in this domain. So they continue the research. Nokia has its own in-house research arm, which is Nokia Bell Labs. So the research continues on what can be the future, what can the future look like, and hence what can be defined as a standard. So that way, beyond 5G is 5G advanced and even 6G. So ideation and standardization efforts are already underway for at least these two future levels of network evolution. Otherwise, the cloud native architecture evolution is currently underway. Software as a service is underway for telecom, and in fact, the 5G rollout itself is going to be under high momentum between now and at least until 2030. So that will mean a lot of custom software to be developed for operator networks worldwide. 40% growth, so it's going to be high action area. Beyond this is 5G advanced and 6G. Yeah, thank you.
Thank you, Madhavi. So the next question is to Bhavya. What is OOPS concept?
So OOPS is basically object-oriented programming, wherein we have a class and structure That's basically the difference between C++ and C. I don't think it's covered in the first year C programming, but I think we'll have to learn it from online resources like Geeks for Geeks or something like that. It's basically object-oriented programming where you have a class and object, and the class and object form the basics of the programming instead of functions like in C.
Bhavya, there's other question to you and Amrita. What is the how is the off-campus opportunities in core ECE companies like NVIDIA, Western Digital?
Okay. So for Western Digital, as far as I know, sometimes some teams take 6 months interns off campus. They usually have like walk-in interviews or something like that. And yeah, for freshers I'm talking. So they have 6 months interns and then they take through that. But I don't think they offer full-time opportunities to freshers without an experience directly off campus.
Uh,
Mostly it's through campus placements and etc. only. Amita, maybe you would like to talk about NVIDIA.
So even in NVIDIA, most of the full-time employment for the new college graduates is through internship and CTO and through college placements. But they do take lateral employees, like with 6 months, 7 months of experience in a different company. They do take lateral employees. So yeah, you can apply through LinkedIn or the yeah, you can apply through LinkedIn or Workday and contact the HR, NVIDIA HR managers. So lateral employment is prevailing, but NCGs they generally take from college placements.
Here comes the last question. This is to Amrita. Like, what is UVM slash VVM? And also, they have asked what is Verilog.
Okay, so UVM is Universal Verification Methodology. So it sets a set of rules. I mean, for a general test bench architecture itself has a set of rules in which you'll have some stimulus generator and you'll have an interface that connects your stimulus with your design, and then you'll have a monitor that will monitor the input output to the device under test. And then there'll be a checker. So a general PV architecture is followed everywhere. But in order to have a uniformity in how these TB architecture is developed throughout the industries, they have this universal verification methodology, which basically gives libraries that you can use to create these structures. So they have like a base. So in UVM, extensively use the object-oriented programming. So UVM provides a base classes that you can inherit from, with which you can easily code all of the functionalities that you require in your test bench system. So that is UVM. VMM was the verification methodology that was used before, and but I think now almost all the companies are in using UVM only. So UVM is the more prevalent one. And Verilog is a hardware description language. So just like how we have C, C++, we use Verilog to code the RTL logic. So in Verilog also has its own syntax and its own functions, which we can use to create logic units. So basically that's what we do. I hope
Yeah. Thank you, everyone. I hope all your questions are answered. So, with this, we end the Q&A session. And guys, we'll share a feedback link to the mentees and the attendees. We'll share the feedback link in the chat box. We would love to hear your feedback. Just a minute, guys. Guys, the feedback link is being shared in the form chat box. Please check it out and do fill the feedback. And I hope all your questions and all your queries are being answered. And also I hope the session is being very informative to every one of the mentees and the other panelists who have attended. Personally, the session was very insightful for me. Being a new college graduate, I have actually learned a lot, how the corporate environment is, how things are being after the college. I thank all the panelists who have joined the session and who have given us a lot more points on the topics that has been covered. I thank each panelist for joining the session and making this session happen. I thank all the mentees and attendees for joining this session. Thank you, everyone.
Thank you all. Bye-bye.
Thank you, Karthiha.
Thank you.